Hello students, welcome to samclasses. Today we'll be doing the chapter alternating current. Now this chapter is very important. A lot of question comes and the way they ask the question is very simple. Basically most of the numericals we get it. If you understand the concepts, the formulas, okay, you'll be able to solve each and every numerical. So you need to understand how to solve the numericals. That's it from the AC part, okay? So always they're targeting the numericals. Be sure that whatever numericals I have done here, you should do it. Now, one very important update. Tomorrow we are taking a mock test and day after tomorrow also. Do share this knowledge with all your friends so that they all are able to write and we can have a lot of number of students who are writing the mock test so that we can get a very good ranking for all of them. And after the test, we'll give a one-on-one call to each and every student. We'll explain them where and what areas they can work and enhance their marks. Okay. So very important from our side. We'll put up a YouTube shorts and a Instagram reel. You can check our WhatsApp group and the Telegram group. Join it. You'll be able to get the way how to attempt the mock test. Okay. So let's start the chapter. Now AC. Let's see. Start it with a short notes. Okay. What is the important part here? What is about AC and what we need to know? The important formulas. That's it. So first, alternating current. So what do you mean by alternating current? A current where the magnitude and the direction changes. What? With the time interval, correct? Now, instantaneous value of AC is given by, if you want the current, I is equal to I naught sin omega t, and if you want the EMF, so E is equal to E naught sin omega t. So we can express this equation in terms of cos also, I've just taken for sine. Okay. What does this I naught and E naught shows? This gives the max or the peak value. Very important. Maximum or the peak value. Now, next we have what is mean or average current. Mean or average current is nothing but 2 I naught by pi. Means 2 by pi times of peak current is the average. EMF also same thing, 2 E naught by pi. Just these values I need to keep in mind, okay? Now most of the devices they measure is RMS value. What is RMS? Root mean square value, okay? So here what we do, first we square it, mean it and then root it. But we say opposite, RMS, okay? All the devices they measure this one only. See, I went like this 1 2 so you can remember everything in order. RMS, this value is most important and we'll be using a lot of this, okay? RMS, IRMS equal to I naught by root 2 means peak value of current by root 2, or VRMS is equal to V naught by root 2, okay? So very simple, very easy, okay? Now this is the graph. So this top one is the peak current, a bit below is IRMS, okay, and a bit below is I average, okay? Very simple. Now, next is a resistor circuit. What is a resistor circuit? A circuit with just one resistance, AC, and then one resistance, okay? So here, my EMF is equal to E naught sin omega t, and my current is also equal to I is equal to I naught sin omega t, okay? So what you can see, current and EMF both are in same phase. If one goes up, the other goes up, one goes down, the other goes down, simple. Next, inductor circuit. So one inductor is just a coil, and then a AC circuit. So here my EMF is equal to E is equal to E naught sine omega t, but my current is equal to, I'm not going into the derivation, I naught sine omega t minus pi by 2. So what you can see, my voltage is leading but the current is lagging. So what you can see, voltage leads current by pi by 2, correct? And we can say same vice versa, current lags. If one is leading, the other has to lag by pi by 2. Clear everyone? Now every device offers some resistance to the current. So what about inductor? Inductors also offers a resistance that is given by the value XL, inductive resistance, okay? That is known as omega L. Omega is what? 2 pi F, okay? So we already know XL is equal to 2 pi F into L. So very important, if they ask you, okay, find the resistance offered by an inductor, they can give this value XL and that is equal to 2 pi F into L. Now, if I connect this inductor with a DC, then what will happen, students? So the moment I connect with a DC, what happens? What is the frequency in a DC? So frequency is illa, 0. The frequency in a DC is what? 0. So this whole resistance which is offered by the inductor becomes 0. So what it does, it blocks AC and it passes DC. Blocks AC, passes DC. Very important, okay? Correct. Next part. What about capacitor circuit? So EMF is equal to E naught sine omega t, and current here becomes ahead of EMF omega t plus pi by 2, correct? by 90 degree. So here current leads by voltage by 90. So if current is leading, so voltage has to lag, correct? Okay. Now, what is the resistance offered by a capacitor? That is given by Xc, and that is equal to 1 by omega c, and that is equal to 1 by 2 pi Fc. Okay, so this we have a capacitor, we have a DC circuit. Now, in case of a DC, what is the frequency again? Frequency is what, sir? 0. So the moment I put 0, it will become 1 by 0, and that is equal to infinity. For a DC circuit, it gives infinite resistance. It almost blocks AC, DC, and allows AC. So we got to know about resistor circuit, capacitor circuit, inductor circuit, everything where current is lagging. Okay, and then what is the resistance offered by the inductor, capacitor, and resistor? Okay, once we're done with all these three with a clear idea, clear concept, we go for LCR. Means we have in a circuit, we have one inductor, one capacitor, and one resistor, all three in the same series. Okay, now, what is the voltage across inductor? That is equal to current, maximum current into the resistance, V is equal to IR. Voltage across capacitor is equal to I naught into XL, and voltage across resistor is equal to I naught into R. Now, this Z is nothing but the net resistance, that is also given a new term, impedance, that is equal to root under of voltage square across resistor plus voltage across inductor minus voltage across capacitor whole square. Same thing, it can be written in form of resistance also, R square plus XL minus XC the whole square. Okay, very simple, very important. Now, in resonance, now what about resonance? Now, resonance is a condition where the resistance offered by inductor and capacitor becomes equal, and then in that case we get the minimum resistance that is offered by only by the resistor, and the net resistance, that is the impedance, is equal to resistance. Okay, so if the resistance is minimum, current has to be maximum. So, and in that case, phi is equal to what? Student, 0. And that is known as the resonant circuit. Now, what is the frequency at resonance? That is equal to 1 by 2 pi root under LC. 1 by 2 pi root under LC. Very important formulas, okay? So these are the important formulas. Let's see the next page. Next, we have a term called quality factor. The quality factor is nothing but it's the voltage across inductor or capacitor divided by voltage across resistor. Okay, it shows how sharpness of the tuning. High quality factor means low energy loss, and high quality factor also means sharp current peak frequency. Okay, so one more formula, we have VL or VC divided by VR. This can also be written as 1 by R root under of L by C, can also be written as omega naught L by R, can also be written as 1 by omega naught RC. Okay, so very simple, these formulas are important. Now, power average equal to VRMS IRMS cos phi. Power factor is not there, but still I have given, that is cos phi is equal to R by Z. Okay, next, what is LC oscillation? We have an inductor, we have a current, what is a capacitor. One time the inductor is getting charged, then charging the capacitor, then the capacitor is discharging and charging the inductor, and it keeps continuing, okay? But in reality, we still have a bit of energy loss, and due to that dampening, what happens? We get a damped oscillation in this. The whole setup behaves like a SHM. Okay, the energy oscillates between inductor and capacitor. Energy is equal to what? Half Li square, and that is equal to what? Half into Q square by C. Correct. Now, in LC oscillation, what is the frequency? That is equal to omega by 2 pi, and that is equal to 1 by 2 pi under root LC. That's it. Now, next, what is a transformer? A transformer is a device to step up or step down the voltage. Now, step up means increase the voltage, step down means decrease the voltage. Now, this formula, voltage in secondary divided by voltage in primary is equal to number of coils or turns in secondary by number of turns in primary, and that is equal to current in primary by current in secondary. Okay, now what is step up? If the number of secondary turns is more than the number of primary, then what will happen? Voltage in secondary will be more than voltage in primary, and due to that, the current in secondary will be less than the current in primary, and that kind of setup is known as step up. What about step down? Just opposite. The number of turns in primary will be more than secondary. Due to that, the voltage across primary will be more than voltage across secondary, and the current will be just opposite. Current in secondary will be more than current in primary. That's it. Now, what are the energy loss? 4 different types of energy losses we have. Flux leakage. How can we correct it? By winding the primary and secondary coil over one another. Resistance in the windings, we can use thick wires. Eddy current, we can use laminated core, and hysteresis by taking a material having low hysteresis loss. So this is the sum up of all the formulas that we need to know. That is like the max we need to know. Okay. Now let's see how to solve the questions. The first question, very simple question. Okay. In a LCR circuit, they have given Voltage is measured across AC voltmeter, and that is 415, 65 volt, and for 204, they're asking the current. So we don't have to do anything. What do you have to do? Very simple. I told you the voltage. First, find for any. What is it? Let's take a inductor. So we have in this case of inductor, okay, 100. So what is the resistance for this inductor? XL, and that is equal to what? Omega L, and that is equal to what? Omega is what? 2 pi into frequency into L. So that is equal to 2 into pi value is what? 3.14 into frequency is what? Given 50 hertz. Here see the frequency is given into the value of inductor is 100. So if you do it, you will get 314. Correct. Now I know I told you voltage across inductor is equal to what? I naught into XL, correct? So that is equal to, so I naught is equal to, voltage is equal to what? Voltage is equal to 204. See, for the inductor, the last part, 204 divided by 314. So if you solve it, you'll get 0.65 ampere. That's it. Clear? You could have done by taking a resistor or across a, what is a capacitor also. Same thing, very simple formula, very simple thing, okay? See, we just know voltage across any device is what? Voltage into resistance. Now, resistance across inductor is different. So that is given by the value XL. So first we need to find what is the resistance offered by an inductor. That is given by this formula XL, and XL is nothing but omega L. Omega is what? 2 pi F, 2 pi into frequency into L. All values are given. Find it out. Now again, very similar question to that. They're asking what is the impedance? Means they're asking about the net resistance, that is Z. So Z is equal to what? Root under of what? R square plus XL minus XC whole square. Now you said, sir, I know R. What about XL and XC? Find it out. So XL is equal to what? Omega L. And XC is equal to what? 1 by omega C. Just now I gave you the formula. So omega L is what? 2 pi F. So 3.14 into frequency is what? 50. Into L value is what? 25.48 millihenry. So 10 power minus 3. And this is equal to 1 by 2 into 3.14 into 50 into 796 microfarad. So what we have is X is equal to 1 by 2 into 3.14 into 50 into 796 into, this is what? Micro 10 power minus 6 farad. Okay. So if you solve this, this will be coming around 8 and this will be coming around 4. If you solve it, approximate 8.000 something it will come, and this is 4. So what you will get the value? Root under of resistance is what? 3 square plus 8 minus 4 whole square is equal to what? See, you can remember this value, correct? That is 5. That's it. Clear? So very simple. You just need to mug up few formulas and you will be able to solve all the questions. Okay. Let's see the next part. A capacitor charged with 30 microfarad is connected to a 27 millihenry. The angular frequency. The moment they say angular frequency, so basically what they're telling you to find omega. Correct. Now, how do we find omega? See, frequency I already know. Okay. For a free oscillation is what? 1 by 2 pi root LC. So what about omega? Omega is equal to, sir, 2 pi f. So 2 pi directly we can do 1 by 2 pi root LC. So that is equal to 1 by root under of 30. L is what? 30 into 10 power minus micro. L is here. 30 milli is there. So we are writing about the capacitor first. Okay. 30 microfarad. So 30 into 10 power minus 6 into 27 into 10 power minus 3 millihenry. Correct. So if you solve it, you will get somewhere around 1 by 9 into 10 power minus 4. Correct. See, 27 into 3 is what? 81. So 9 will come out. Okay. And this zeros is how many? 639 and minus 8. So 10 power minus 8 directly you connect 10 power minus 4. So it is something about 10,000 by 9. So you'll get 1.1 into 10 power 3. Okay, radian per seconds. Clear? So very simple. The moment they say angular frequency, they're always asking about omega. The moment they say frequency, it is F. The moment angular frequency is omega. Okay. Next question. Again, same thing. They have given LCR circuit is there. Okay. Now, VL is given, VR is given, VC is given. They're asking you what is the supply voltage. So VS is nothing but root under of what? VR square plus VL minus VC whole square. Correct. That's the formula only, no? Correct. So if you put up the value, this is equal to 4 square plus 6 minus 3 whole square. This is again 4 square plus That is 16 plus 9, that is equal to 5 volt. Clear? So very simple questions are here, student. Okay. Understand, don't get confused. If you have any doubt, put it in the comment section. Okay. We'll try to rectify it. We'll try to explain it again. So nothing is there, just you need to remember the formula and you'll be able to solve it. Again, the resonant angular frequency means they're asking for omega. With L equal to this, C equal to this, R is equal to this. See, omega is equal to what? 2 pi f. So that is equal to 2 pi, and frequency is equal to what? 1 by 2 pi root LC. So basically, they're asking 1 by root LC. So 1 by root LC value is what? I already know. So what is the value I'll get? Root under of 3. L is what? 3 into 27 into 10 power. How much? Minus 6. So I'll get 1 by 27 into 3 is what? 81. So 9 will come out into 10 power minus 3. Correct. So again, 1000 by 9. See, very simple. The values also don't change. 111 radian per second. Correct. So very simple questions are here. Nothing much is there. Okay. So let's see the next question. Again, see the question of quality factor. Just now we did quality factor is equal to what, student? Directly formula you'll put, sir. What is the formula, sir? 1 by R root under of L by C. Okay, that's it. You can always also keep it omega naught L by, though we don't need that much. That's it. See, directly formula based, and students are getting scared, sir. Comet K, very difficult. Having formulas, make sure that you know each and every one by heart properly. Okay. Now, the variance of impedance Z in the LCR circuit. Now, see, understand, here is a short trick. We know Z is equal to what? Root under of R square plus XL minus XC. Now, whenever XL and XC becomes equal, that case, what will happen when XL equal to XC, Z will be equal to R. So Z becomes equal to R, and that we'll get the minimum value here only. See, Z is decreasing and then increasing. Not in any other case, it is not happening. Okay, in none of the cases it is happening. Z equal to R. So which is the diagram which is showing? Let's see. Clear. Next, the instantaneous current. Okay. See, they gave I is equal to 5 sine omega t. Now you already remember what is the formula of I? I is equal to I naught sine 314. So this is my omega and t. So I just need I naught. I need I naught. So what is my I naught? I naught is very easy, 5. Now I told you IRMS value is very important. That is equal to I naught by root 2. That is equal to 5 by root 2. So 5 by root 2 is how much? 3.54. Calculate root 2 value is what? 1.41. You can divide by 1.4 also. More than enough. Okay. Two inductors, each of inductance L, are joined in parallel. So you need to understand parallel combination of inductor. Parallel combination of inductor. So when you have two inductors, you join them. So one by, it behaves like normal parallel, okay? Just like what is the resistor? L1 plus 1 by L2. Since both are same, so 1 by L plus 1 by L. So that is equal to 2 by L. So L equivalent is equal to what? L by 2. That's it. Clear? What is difficulty here, students? Correct. Now next, at resonance, the value of power factor. Now power factor is not there, so it is deleted portion. Still I'm showing it. Power factor is nothing but cos phi, that is given by R by Z. At resonance, what happens? At resonance, what happens? XL equal to XC. So what happens? Z is equal to R. So R by R means 1. That's it. Clear? So this is also simple, just I showed it, but it's not there, okay? Next, in which of the following circuits it exhibits resonance? See, for resonance, you need one inductor and one capacitor. So resistance and this, they can't cancel because XL is equal to XC. You need an inductor and a capacitor to cancel each other. This also not possible, this also not possible. Only possible case, LCR circuit. Okay. Now, next question, which of the following is electromagnetic analog of mass? Directly inductance basically, and self-inductance is also okay. Okay, so this sums up the whole chapter of AC. We've done every questions. The questions of transformers I've taken it, I think so, in EMI section. Okay, so do go through from there. Very simple questions are there.